Greetings everyone. This is Ishtiak Ahmed Safin. Today I will present my research on process optimization and defect control in cold rolling process of high strength steel. In simple words, this is a topic about how we actually make strong parts more accurately with fewer defects and better surface quality. So this is how actually we'll go the presentation. I will demonstrate every topic one by one. So as we can see that cold rolling forming process is a manufacturing process where a long steel strip is actually gradually bent through several roll stands to create a final shape. So this is important because it is high productivity, it's low material waste, and it is used for making long structural parts. High strength steel is also valuable because it makes parts higher, lighter, and stronger. However, high strength steel is hard to control. Even small shape errors can cause poor assembly, rework, and waste extra cost. So improving accuracy actually and surface quality is very important for the industry. The main problem is that the steel may look correct during the forming, but the thing is, but defect can actually appear after forming force is removed. So the common defect is spring back. This means that the steel bends slightly after forming because it tries to recover its original shape. The other difference includes twists, bowling, shape age, and residual stress and surface stretches. This happens because stress and strain are not actually evenly spread throughout the profile. So the key challenge is not only forming the steel but also keeping the final shape accurately and the surface is acceptable for the industrial use. The literature shows like the four main parts. First is the process machines, which explains how the stress and strain will actually depend on the forming process. The second one is defect control, which focuses on like spring back, streets, and edge webs. The third one is optimization using like tools like FEM, DOE, and RSM. The fourth one is monitoring the data and the real-time feedback. The gap is also studies and focuses on many like one defects at a time, but in real production several defects actually can come together. So this leads to my research question: can an integrated optimization and defect control approach improve dimensional accuracy and surface quality under the industrial condition? So in this phase, we're gonna talk about the research design. The research design is a comparison, compresses the baseline setup with an optimized setup. The first is the current process schedule is used as a baseline. Second one is FEM model is calibrated using the experimental research. The third one is DOE and ISM is used to search for the better process setting such as roll gap, stand, spacing, form, angle, and speed. The fourth one is the optimized variation trial, which is carried out. Finally, the baseline and optimization samples are actually compared using shape and surface quality measurements. This U design actually uses 30 samples in total, which is like 15 baseline and 15 is optimized samples. The design has several advantages like it directly compares current and improved settings. FEM reduces actually unnecessary physical trials. DOE and RSM test several variables in a structured way. And also the design actually checks both shapes accurately and surface quality. However, there are some limitations, as we know that the study only tests one steel grade and one profile. FMA also depends on calibration and assumption. For that, surface scoring may actually include some human judgment. more industrial testing would actually needed before applying for widely usage. The study actually measures both variables and quality outcomes. The variable includes like rolling grab, internal space, stand distance, forming angles, and forming speed. This outcome includes like swing back angles, playing heights, width deviation, twist bowling, residual space, and surface roughness. The success target is at least 20% lower spring bed, at least 15% lower dimensional deviation, and no increase in surface damage. To conclude, cold room farming process is useful because it produces long, steel, and efficient with less wastage. So in the future, this approach can actually improve real-time monitoring and control. Thank you for listening to me.